Okay, welcome to this video where I do 2016 question C3 higher level surface geometry. So the image on the right shows a package for jelly beans. The package consists of a cardboard transition piece connecting the square base to a circular top. So it's a loft from the square to the circle. They join together. The transition is achieved using triangulation as shown. So going from the base to the point, okay, and elements down here. Figure C3 shows the plan and elevation of a package. Also shown are triangular divisions, a partial surface development, so some of it is completed here. Draw the given plan and elevation to include the straight line elements of the curved surface as shown. So that's part A. So we get started on that. So the square is inclined at 30 degrees to the XY line. The length is 60. So our plan view. Right, we'll get our center point. Right, we'll draw in our circle now in plan. There we go. Right, now our hidden detail lines. Okay, then we'll get these points, we'll label these points and get the remaining ones. So C, E, A, H, D, B. Now to get points F and G, right, it's basically the divisions here 60, 30. Quick way of doing it is take your compass, set to the radius of the circle, swing an arc from E there, turn it around, put your compass on the H, swing your arc there and swing your arc up there. It's a fast way of doing it. Okay, you can draw your lines through there. And then this point joined to A. So there's F, there's G. Alright, the altitudes are 25 and 100. So we're going to have to bring all those points up. So 25 up. And then 100. get the B just across there. There's B in elevation, so we can join them to the relevant points. And A, forgot to bring A up. Right, to get the top 2 points here, draw a horizontal line across through the circle. It's done. So straight up here. Okay, now okay, now we have to get point E in elevation is right here. So E joins to C and E joins to A. So there's A, C, there's D. So A joins to E, C joins to E. Sorry, I joined the wrong points there. So C to A, or E to A, C to E, okay, C to E is done. Now we have to bring point F up. So there's point F. We have to get point G up. So there's point G. We have to get point H up. Okay, and we don't need to, well, we'll bring it up for the crack here, that one there. Right, there's G. Okay, there's H. Okay, so A joins to F, A joins to G as well. So we're going to join A to F, A to G, and then A joins to H, and H joins to D. D joins this point here. Now, the next part of the question says, okay, we have to draw the true shape of surface ACE. So ACE, that appears as an edge here. And then, okay, determine the true length of the straight line AF, showing all necessary constructions. Okay, now, so we can put it out here at the side. We have to do a development, so we do. The true length of a line is seen in view looking perpendicular to the line. So if a line is on the XY line or parallel to the XY line in elevation, it's a true length in plan. Okay, if a line is on XY line or is parallel to the XY line in plan, it's a true length in elevation. So C to A is on the XY line in elevation. So C to A is a true length in plan. So I'm just going to move out along my XY line here. Okay, just a tad up. It doesn't necessarily have to be a small bit up. I'm going to mark 60 there on it. So that's the true length of C to A. Okay, now I'm going to get the true length of C to E. Right, so in plan, I'm going to draw a line parallel to the XY line. Okay, and I'm going to put my compass on C. And I'm going to rotate E up. I'm going to bring it straight up. Okay, now I'm going to join C to this point here. So that's the true length of C to E because it's now parallel to the XY line in plan. So I'm going to put my compass on C. So a sec now, I just want to get that perfect. So now I'm going to swing from C. Okay, now E to A is the same as E to C. They're the same distance because they're the same distance here in plan. Just to prove it to you, okay, if you drew a line parallel to the XY line in plan, rotated A downward, or sorry, not A, E. Okay, and took the length of A to the new E. They're the same there. Now, so we can take our compass and swing from A. And then that's the true length, or true shape of C to E. Now we have to get the true shape of line A to F. So we're going to take our compass and we're going to rotate point F down onto the XY line, or down onto a line parallel to the XY line, straight up. Okay, now straight across from F, and this is it there. So we're going to put our compass there on the line and bring it to A. And this is the true length of A to F. Now, I think that might be a little hard for someone to, or a student to understand. So I'm just going to show you a different construction. Now, what I mean when I say it's a bit hard for a student to understand, it's more about seeing what's happening on the sheet is the hard part for them. So just maybe a simpler way, or easier way for you to do it is take the distance from take the distance from A to F and put it up here on a construction line, join to here, and there's the true length of A to F. And just to prove to you, if I was to remark it there on the construction that I had done, it'd be the same. So A to F TL, true length. So compass on A, swing your arc. Now set your compass to the distance between E to F in plan. Line E to F is parallel to the XY line elevation, so it's the true length in plan. So swing there. Okay, now that's point F. Now we're rolling. So now we're going to take F to G and we're going to swing the arc. Now A to G is a true length as well, and A to G is the same as A to F, so you can label that A to G as well. So we're going to reset our compass there, and we're going to swing our arc from A, which is, I pretty much have it there. Okay, now sorry, I don't think A to G is the same as A to F, so I'm just going to test that. Look, so I'm just going to put my compass here, or my T square there, rotate it down, straight up. Okay, so I'm going to put my compass on A, bring it there, and then just swing again from A. No, it is. Alright. Now we have to do A to H. So A to H will definitely be the same as A to E. So, here. Or C to E, same thing. So you can swing there, that's point G, or sorry, that's not point G, point G, that was point G up there, but this arc that we're swinging is going to be getting A to H, so distance from G to H here, and swing to here. Now, there's point H. Okay, and we can freehand sketch these in, so I'll do that now. So that's part C complete. Alright, so that's it there. Now, the next part, it says determine the dihedral angle between surface A, BC and ABD. Now, in order to see the dihedral angle between two surfaces, you need to see the line of intersection as a point. In order to see the line of intersection as a point, you look along the true length of a line. That line. If so many students, okay, that I see, think immediately just to look along the line. That's not what you do. You have to check, is it a true length? If A to B is parallel to the XY line in plan, it's a true length in elevation. AB is not parallel to the XY line in plan, so AB is not a true length in elevation. If AB is parallel to the XY line in elevation, it's a true length in plan, and AB is not parallel to the XY line in elevation, so it's not a true length in plan. So, in order to see the true length of the line, we need to look perpendicular to it. Now, I know I used rotations there a moment ago to see the true length of lines, okay, but I would never use rotations to see the true length of a line in dihedral angle questions. So I projected parallel there to line AB, and we're going to project these points onwards, C and D. So now, C and D, D1/C1 are on the X1, Y1 line. So point B is 25 mil from the X1, Y1 line, because the height remains the same. Point A is on the X1, Y1 line, because it's on the XY line elevation. Now, this is the true length of the line of intersection AB. So we're going to look along that line of intersection. So we're looking along that line of intersection. So there's the angle. The X2, Y2 line is perpendicular to them. Okay, now we can also draw in a datum line just to save the amount of space required. So I'm just going to draw a line parallel to the X1, Y1 line back. I call it datum. So I'm going to put my compass on the datum line, bring it to B, lift, follow it along here. I'm going to mark it in. So I can just bring this on more. So this is A2, B2. So line A2 or A to B is appearing as a point. Then we're going to take the distance of our X1, Y1 line back to D. Okay, and we're going to put it on here. So there's D2, and then C2 is here. So there's C2. So join the lines together, dihedral angle, measure the angle and write it in. So measure the angle and write it in. I just don't know this one. Here we go. So the dihedral angle is 125. Right. Yes. That's the question done. Cheers, thank you, bye bye.